All right, flow metrics. So there's no lack of data around. There's like so many metrics out there. The problem is that at the business level, it's rare to find a compelling set of visuals that have metrics that resonate from a business perspective. And if you contrast this with folks practicing DevOps, if you've got your mean time to recover and you've got your change failure rate, change success rate, those are valid metrics and individual teams can make improved decisions based on those metrics. But if you're looking, if you come up a level, look at the high level, it's hard to find opportunities to improve based on MTTR. Same thing with dev and IT ops teams using Scrum and Kanban boards. They can make their work in progress visible across all the entire team, and that helps them make decisions on capacity and allocation at the team level. But how can we make better decisions up at the higher level, at the business level? So flow metrics, basically, what's the point here? They bring visibility to the outcomes, right? So, we only got feature work done last month. We didn't get any defects or any technical debt work items done. That feature that we promised big customer that we were going to deliver early last month got delayed a month. So meaningful outcomes that business people can wrap their head around. The other benefit of outcome-based metrics is the feedback loops that they provide, right? Feedback loops for people to make better decisions off of them. Should we allocate more capacity to fix technical debt next month? Should we consider just continuing to do more feature work next month? These are the questions that get provoked when we talk about flow metrics. And today's going to be sort of like a crash course real quickly in 5 flow metrics. So we're just going to really quickly why, how, and then Mick's going to come and tell us a story about each one. So we're looking at flow distribution. What is that? It's a measure to understand the trade-offs of the different types of work that we're doing. So flow distribution here, what we're really doing here is having a conversation about prioritization. What is our strategy and what are our explicit prioritization policies? Flow distribution is going to show that for us, right? It's going to provoke these necessary conversations. If our distribution of the work items looks something like this, where we're doing mostly features and then some defects, not so many risks, you can't, if you just continue to deliver features, you can't say that we had a strategy to prioritize fixing technical debt when it didn't happen, right? A decision to do one thing is a decision to delay something else. Everything can't be a priority one, right? This forces that necessary conversation to occur. And this is what the business and the IT leadership needs to understand. So one way to look at this, if we categorize work items, we can visualize their WIP and visualize their work in progress limits like this. So here's a Kanban board where we're planning out the desired, the strategic direction on what this ratio is going to be. The ratio for flow distribution, it's fungible, and you can change it depending on your strategy. Do we want to do more features this month, or do we need to work on technical debt? What makes sense in our context? If you look at a board like this, you can allocate your work in progress limits per work item type. So on this board, we've got a WIP limit of 5 features, 5 defects, 1 risk, and 3 debts. But what's happened, we've just continued to do more feature work. We went way over our work in progress limits on the feature work there. So if the team has capacity to do 14 things at a time, that's what this work in progress limit says, that allows you to allocate work items based on the type of work that you want to get done. And so it helps others see the impacts of conflicting priorities across the team and the organization. All right, Mick, first story.
So This is a figure out of the book, and it's actually a dramatization of one of our releases. And this is actually the release of Tasktop Hub and the flow distribution story that happened. And we realized, and I think you heard some of this journey today with what Mark said, what Kyle said, Tasktop Sync grew quite fast as a new piece of infrastructure, but it was built on the wrong platform. For Mark, it wasn't the wrong platform, it was Eclipse. But for many others who were not developers, who were not familiar with Eclipse, who didn't care about our own legacy of building developer tools, it was the wrong kind of platform. It was not the kind of back-end Java infrastructure platform that organizations wanted. And so we realized, like many other tech companies, that we needed to re-platform, and we needed to do this quickly. And we needed to bring this new experience of solving the same problem, but at a much bigger scale, and in a much more scalable way from a user interface and a configuration point of view. We need to bring this to market very quickly. So of course, we had to focus a lot on creating all of those features that organizations need in Sync, doing it in better ways, because we realized JavaScript was going to be more successful than Groovy. It became very obvious a few years ago when we started on this journey. And so again, that feature push became a critical factor of our success of delivering that experience to you before you had to go and hire 20 administrators for Sync as it scaled up to these hundreds of integrations and thousands of staff. So we realized that, and we realized that we were going to have to take on some technical debt as we did this, and we thought these were disciplined decisions. But you can actually see over here that there was something that we didn't quite realize, because that light gray ball that gets very thick in the middle, those were all these defects that came in. We did not quite plan for Tasktop Hub to be running at large-scale production before its GA, because the customer was needing to move that quickly to this new product. So those were the things that we didn't plan, that just the rate of adoption just exceeded what we expected in terms of the size and complexity of the deployment, which then meant that all those crazy defects that we get around your different authentication systems and your customizations of SSO and the amazing things that you hear done within government organizations and in commercial organizations, all of those things came in all at once, which then, of course, completely crippled our feature delivery in a way that we had to really quickly forecast because, of course, we wanted to bring those new features to you. And this lens, this is something that the business needed to understand because, of course, pre-sales people like Jeff and Mara will have made promises to certain customers and so on. So actually having an organizational perspective on, and they're laughing in the back, uncomfortably. So having a perspective from the business point of view, because of course all the engineering and product teams know this already, the agile teams know that this is happening, but making sure that the business understands flow distribution, at least at this high level, not at the level of exactly which kind of architecture API you need to add, but at this level so you can plan accordingly, I realized was absolutely critical so that we could, as a company, make the right decisions and set the right expectations. And as we, of course, work down those defects and move towards the higher velocity of feature delivery that we needed. So.
All right. Okay, next one up is flow velocity. This is one of the more simpler metrics. We're just measuring, we're just counting basically how many things did we get done over a particular period of time. Things as in work items. This is the flow velocity chart from our board game. It's a board game simulation to teach people about Kanban and flow metrics. And up on the right, you'll see in the black is a histogram of how many work items were completed each day. And so that's what flow velocity is. This is a productivity metric. It's also called throughput. I'm going to take this moment to introduce time thief, unplanned work. Unplanned work can impact your throughput numbers, your flow velocity numbers, because if you were, one reason we use flow velocity so that we can calculate the trends over time and we can start to set better expectations for when we're going to deliver something. Our forecasts, our estimates can be improved with respect to the delivery rates. But when we look at unplanned work, if you're tracking unplanned work, it will show up in your metrics. And if you have a lot of it, then you can start to see why some work gets delayed and the relationship between your flow time and your flow velocity. So you can do an experiment and ask that your hypothesis might be something like, if our flow time increases, does our throughput, does our flow velocity go down? And if you have 3 emergencies, the unplanned work is in yellow here. If 3 emergencies pop up 1 week, will it delay the planned work that was intended to be delivered that week? Probably so, because unplanned work impacts planned work. Right? Unplanned work delays planned work. All right, your story here.
So this is, I'm going to tell you another story right now, and this was something that was a surprise to me in terms of looking at our own flow metrics, our own flow dashboard, even though someone like Dominica would say it shouldn't be a surprise because I've read her book, I've read the Donna Reinertsen product development flow book that talks about loading your teams with too much WIP. But somehow, even having read those books, people in my role sometimes have a tendency of loading their teams with too much WIP. So the really interesting thing is, and I think I just want you to think back before you stare at this chart too much, to Dave's talk today, is that we've got complexity in our organizations. We've got, from the point of view of the software, of the team structures, and so on. And if we don't have a way of observing those, as Dave said empirically, and knowing that if we do this, the outcome is positive or the outcome is negative, it gets very difficult for us to make the right organizational decisions. And of course, we should always aim to empower, in the end, our product teams, our value streams, our scrum teams, and so on, but we still have to make those organizational decisions around, are we going to bet the company on this new product, the way that Boeing will bet their company on every single aircraft, a new aircraft that they make. So this is an old snapshot of a couple of our value streams. This is back from, I think June. And what you can see here is the flow distribution. So Dominica just showed you the flow distribution. And you can see that, again, in the case of this product value stream, we again needed to get those features out because you were demanding those features. And you know the kind of the features sometimes around integrations, around new connectors, and so on. So features were key. And you can see those features taking more and more of the flow distribution. But when that happens, our ability, or the team's ability, to do the work they know they need to do in order to enable us to deliver more features in the future, of course, goes down, and because that technical debt goes up. And you actually see here that they had to start working off that technical debt, and that, again, the flow velocity of features suffered as a result, because now, that part I understood when this was happening, that we were accepting. We were going to go through another couple cycles, a couple quarters of more of a feature push, and then because we understand flow distribution, the team would have enough of a chance to work off that technical debt after they got over some of those humps. The thing that was much less obvious, and this is where one of Dominica's time thieves around dependencies comes in, that I think she'll talk about in a moment, is that the kinds of features the team was implementing were features that spanned value streams. And those dependencies can be super tricky, especially if you don't have exactly the right kind of architecture APIs. So you can actually see that flow load bar. This is how many features the team is working on concurrently go up and up and up. And as flow load increases, because it's a measure of WIP, of work in progress, velocity decreases. So we just kept making things worse and worse and worse because of the fact that we hadn't solved that root problem, which is the dependencies between the value streams. Because for some kinds of advanced features, we have to change quite a bit. We have to change our core SDKs, our integration factory, multiple integrations, and those kinds of things. If we add a whole new kind of artifact that we're going to synchronize and implement for you. So again, this kind of thing is now made visible so that we can help give the teams the time to do the thing they know they need to do, which is to focus on re-architect around those new kinds of dependencies that they've never had to before. And again, the key thing is that the thing that the teams already know becomes explicit to the business through this kind of observation.
All right, next up is flow load. I have a particular fondness for flow load. This is your work in progress. This is all your work. Your work in your ticketing system, all the Post-its around your monitor, all the unplanned work, all the invisible work, your to-do list, everything, all of it. It's partially completed work, right? Why do we measure it? Because it's the primary factor when you calculate any kind of speed metric. And the benefit from it is that it provokes conversations about people being overloaded, right? It is a leading indicator. We don't get very many leading indicators in our line of work, right? Lead time, cycle time, throughput, I mean, those are velocity, those are all trailing indicators. You don't know how long something took to do until it's done. With work in progress, flow load, you know when it's high, things are going to take longer. Just like this freeway here. Right? You know when you get on the freeway and it's backed up that your throughput is going to be minimal. Your commute home is going to be much longer. Right? High WIP limits means that you're waiting. Right? You're waiting on service longer. You're waiting on dependencies. You're waiting for people to become available. And so the single most important factor that impacts queue size is capacity utilization. As computers, as they get utilized higher and higher, their performance slows down. Same thing happens with people, especially in areas of high variability, like in operations. Right? And I like to say that we don't let our computers get to 100% capacity utilization. So why do we let our people? Oftentimes because we have a hard time saying no. We take on more work than we have capacity to do, and we burden ourselves with too much work in progress, and then things get delayed. So the higher the utilization, the longer the wait. Here's some math for folks. This is queuing theory. We're looking at wait times here. The benefit of looking at this is that you can see that an increase in queue size is directly related to capacity utilization. And anytime you get over 80% or so utilized, you're going to introduce a lot of wait time into the system. It's why some organizations take 20% out. Like Google used to have Fridays off to work on whatever they wanted to do. It's a way to introduce slack into the system. Although at Google, I think people had said now we're utilized at 120%. But the idea behind it is good. If your goal is speed, then consider managing by queues instead of Gantt charts. Right? Because Gantt charts, you can't see the impacts from dependencies and wait time. Right? Keeping people busy all the time is neither efficient or effective because people get overbooked.
And so this is, again, I already touched on this a little bit, but it's one thing to read about it, kind of believe that story, believe that the last age, the age of mass production, that of course it was realized that if you utilize the robots as per the goal, over 80%, you're actually going to slow down how many machines you deliver, how many cars you may deliver. For me, it was a very different experience to actually see this in action, that the more we loaded up, the value streams in this case, the longer we were waiting for features. And if we don't have that slack, whether it's for unplanned work or because things are getting bigger and so on, estimation's never perfect, I could now actually see that this was the effect, and we had to do things differently because this intuition that I think a lot of us have, that the more we utilize resources, the more we get out, is actually wrong if you're scaling production. And not only do the theories behind Dominika's book and Reinerson's book say this, it's now possible for you to see it. And by the way, that 80% number, I think this is the important thing about the empirical lessons. That 80% number, maybe you've got the world's most productive organization. Maybe your number is 90%, right? Maybe you can utilize higher, or maybe it's lower. But the bottom line is you can actually tune this to your organization's needs when you're able to measure it and see this information, just the way that Select Medical is able to start seeing it today. So.
All right, flow time. So this is a scatter plot chart where we're just calculating how long work takes to be completed. So the horizontal axis is the number of days work took to complete, and the vertical axis is the number of days work took to complete. Horizontal axis is the date that the work was completed. And we're plotting a dot on this chart for each work item that was completed. And so if you look at the arrow in the third week of September, you can see that that one item took almost 15 days to do. Why do we track flow time? Because it helps us understand what the probability is of something taking, how long something's going to take. What I was used to in the past was people would set an estimate and then they would set a date. We shall meet this date. We're going to deliver this work by this date. And we frequently miss the date. So that's a deterministic approach. We're trying to take a more probabilistic approach in saying, what's the probability of meeting this time frame? We're trying to be approximately right instead of exactly wrong, right, with probability. One of the main reasons we measure flow time is because it's one of the biggest complaints. Things take too long. When people complain about things take too long, then okay, well, let's measure how long do they actually take, and then we can set better expectations by being more predictable. Quick review on where the clock starts and where it stops. There's a lot of arguments that will happen when you get into any kind of discussion on lead time or cycle time. So we just tried to remove that argument and talk about flow time. It's not a new term. It's been used before in the past. But in talking with customers, we said, well, what makes sense in your organization? Where do you want to start the clock? Because not everybody wants to start the clock when a customer made a request. And frequently, people would come back and say, in our context, it makes sense to start the clock when we decided that we're actually going to do something. And we don't really care if we're not going to do it. But from the time we decided that we're going to do something, from when product management or product owners said, yes, let's do this, let's start the clock ticking and end it when it is done. And done is up for debate too. Some customers want it to be passed when something's delivered to see how much business value they've derived from it. I've got some other metrics on here, but I just really want to point out that flow time is a duration, right? It's the clock starts and then it ends, right? It doesn't stop in the middle because a holiday came around.
Dominica, go back a slide. This, if I am able to use as a metric the number of times I've sat and listened to a conference with Dominica, say DevOps Enterprise Summit, and we're texting each other saying, this is so wrong because someone's just presented lead time on their slides, and all they're doing is measuring this tiny slice in development, right? Story open to story close, or to code commit to code deploy. None of those are lead time metrics. And as you saw in Suzette's and Robin's presentations, we can do very poorly by measuring the wrong things, or even measuring things the wrong way. So the measure of lead time, actually, I learned from Dominica's book, because I had some frustrations with it myself. It's also wrong. My frustrations came from the fact that when I was working in open source projects, it was nothing like working on car orders, right? Every car that is ordered from BMW ends up delivering at some point. Lead time matters. On a popular open source project, on a popular product, the number of requests could be 1,000 times the number of work that you do, right? Apple has millions of open requests they're not even going to look at any point in the future. So you basically have infinite lead time. The lead time metric itself does not make sense for popular software products that have more customer requests. So Dominica introduced this metric actually from the manufacturing literature, which is, again, flow time. And this is the one we think is most meaningful. Of course, you'll care if you have many things on your backlog, of your lead time backlog that you haven't started, but we've realized that we've got to stop having a debate around what flow time and cycle time are. Cycle time's the small thing from stage to stage. Lead time's the end-to-end thing. And the most important thing we've learned is to measure flow time from when you decide to start the work, it enters your value stream, to when you finish, because that will be your predictive performance, much the way lead time is in manufacturing today.
Yeah, it's like when you were talking about Apple, how much work is in their backlog that they're never going to do. And that's why I like to use the term options for backlog, because it's a term that business people understand. These are options. We might do them, we might not do them.
And so, stay here still, Dominica. I want to restate a story I heard from actually Nationwide at the DevOps Enterprise Summit. Kevin Fisher illustrated this very well by saying, illustrate the dangers of thinking of cycle time as flow time or as lead time. So when we were on this journey with Nationwide of measuring end-to-end lead time and learned some of these things that Dominica talked about in their book, we discovered through this process that for Nationwide, as Kevin told it, 2.5% of the time spent delivering something was in development, right? So if you're trying to now hire 10 times more developers, you might get marginally more result, because their bottleneck was not there. But if you measure end-to-end, of course, you'll then actually be able to look what's taking the most time. Is it something upstream? Is it something downstream with having a change advisory board? What is it? You'll be able to ask the right questions rather than having this knee-jerk reaction of deciding that you need to hire way more developers. So I think, again, we see this. If you can get started with a flow metric, we think this is the best one for you to start with. Just again, focus on measuring it end to end, rather than boiling the ocean and figuring out every flow metric and how it's going to interact with all your other metrics, which you'll probably still have.
All right, flow efficiency. This is a way for you to figure out how much wait time is in your system. When people estimate and they say, how long is that going to take you to do? And you say, oh, that's going to take me 4 hours. Well, that takes you 4 hours if you don't get interrupted, or you don't have to do some context switching, or you don't have to wait on the security person to get back to you to tell you something. And so a friend of mine once said, if you're going to measure anything, measure the wait time in the system, because work spends a lot more time in wait typically than it does in a work state. So that's what flow efficiency is all about. We're trying to learn just end to end of your flow time, how much of that work was actually waiting. These are where the bottlenecks are going to be. In order to capture that, though, we need to be able to see buffers or wait states. So in a regular Kanban like this, normally you just see work states, to do, analyze, dev, test, ops, done, whatever. But if we're going to start tracking the ratio of wait time to work time, it does require you to map a wait state in your system so we can start to make that calculation. This would be how you're going to do it for one board, which might be okay for a team to do, but how are you going to scale that out across hundreds of different teams? Quite a challenge. When you've got lots and lots of different boards and handoffs between teams and dependencies across teams, it's almost impossible to see where the wait times are. Very challenging. So it's something that we are tackling.
So I'll tell one more quick story here, and this is the flow efficiency metric is, I think, once you've got some of these other pieces in place, it's a little bit more sophisticated. It's one of the ones that I've noticed within our customers becomes an extremely telling one of where you need to focus to improve your delivery, to get things out of your people's way. What our own experience with it has been interesting. So we have Tasktop is basically built on an enterprise Java stack with different bits and pieces. And some of our engineers and product developers, they decided that for some of the new things that we're doing, they want to experiment with some of the more modern approaches. So basically Scala and TypeScript, Kafka, and a few other pieces, in addition to the Angular and Vertex stuff that we were doing. So of course, the argument's made that we're going to be much more productive with a stack. And I've heard that argument many times. I've made that argument myself many times as a developer. But I said, sure, if you really think you're going to be more productive with a stack, OK, go for it. And let's see what happens. And the amazing thing to me was that 6 months in, we could actually see that on the stack, because I was going to play the devil's advocate, that the flow efficiency was much, much higher on the stack. So I think the jury's still out on this. But the bottom line is from our own flow metrics, I actually now realize what the team was saying is that they're able to minimize their dependencies because they've got some more dynamic aspects to these languages that they can leverage. They don't have to go and have lunch with 8 people to go change an API. They can work around these things. And they're actually able to move faster. So again, empirical evidence that we can see that maybe the things that we've learned on this product's value stream and the new programming languages they're using, maybe we should look at applying those to some of the other things that we're doing. But taking the guesswork out of it and actually seeing they're able to deliver more efficiently, just like they thought they were.
Let's talk real briefly about gaming metrics and some other considerations. I was at the Agile conference once and out in the vendor space, and I heard somebody ask a vendor, can you please exclude weekends from your lead time metrics? And I couldn't help myself. It just came out. Like, why would you want to do that? And they said, well, our annual reviews, we're supposed to cut our lead time in half. Our merit reviews are based on that. So any metric is fairly easy to be gamed, and it's a good conversation to have with your organization. How will your teams game these metrics? Tell me how you're going to measure me, and I'll tell you how I'm going to behave. If you're going to measure me on just lead time, then we're going to probably set aside these other metrics so that we can put this emphasis on how we're being measured. And that's why a balanced set of metrics, it can be so useful. Then you can compare, how does a change in your flow time or your quality metric impact some of these other metrics? Helps keep things in line. Keep in mind that all metrics are based on assumptions. And all you have to do to discredit a metric is to question the assumption. So when somebody says, let's exclude weekends from our flow time or our lead time metrics, that's an example of questioning the assumption. Okay, well, what about holidays? What about sick time? Well, let's just measure the actual hours that we work. You just go down a rat hole with that. So when you're implementing some of these metrics, consider how people might game them based on how they're being measured. Because what we measure impacts people because people value what's measured. All right, last story, Mick.
So this is just an example. Again, I think the whole goal with these metrics is to create the minimal number of these flow metrics that provides this balance and also provides you a way of looking at what is this dynamic system. And again, this very complex system of how your teams collaborate and to build great software and how information flows between them. And so I'll give you an example of this. This was really interesting, where that one team who had the higher flow load, who was not able to deliver those features, but felt the pressure from the business side, from our customers, from our teams to deliver those features, because one of the metrics in the flow framework that's used for balance is actually measuring the happiness of the teams. In our case, through Employee Net Promoter Score, we can see that through that, because they weren't given the opportunity to do the re-architecture they needed, it actually caused a drop in the Employee Net Promoter Score. So this is, again, with the flow metrics, we've come up with this kind of balance so that we can see now we needed to give that team more time. We need to get away from this kind of flow distribution that was getting in our way. And again, the balance of these metrics, and including, as Mark said, the people aspect to it, we actually think is critical. Because again, that'll be another leading indicator of inefficiency, and your team's actually not being able to deliver that they want to. And then you'll be able to, again, go in, talk to the people doing it, figure out, is it architecture? Is it a change with security processes or regulatory processes? You'll be able to ask the right questions rather than having everyone feel frustrated.
Just to recap on takeaways and the benefits, we want the metrics to be tied to business value. We want them based on outcomes and not activities, not lines of code, not the number of X things per day, but real outcomes in ways that we can get quick feedback loops to improve decisions. That's what metrics to us is all about. How do we make better decisions? How do we start? I'm going to take this. We're going to start with just how to get started. One artifact, one value stream, one metric.
Yeah, and because you can imagine, you can get started trying to do all the flow metrics, trying to incorporate the 18 or 48 metrics that you already have and figure out how these dovetail. We're actually suggesting a very different start. Just do it end to end, but you can do it across a small team, a smaller product value stream, a smaller project that you're trying to modernize, and just pick one artifact, one, like a feature, or a security story, it could be anything, right? A risk in that case, one value stream, and then one metric, like flow time, and start with that.
All right, that's it for us. Thanks for your time.